Today we will be seeing some new topic called Prism. So what are the topics that we will be discussing today are concept of prism, what is prism, then we will be seeing angle of deviation, angle of minimum deviation, that is del m, relation between del m and mu. What is mu? Mu is the refractive index of the prism, which we will be finding the relation of. Okay, then thin prism, and we will see some numericals related to this topic. Okay, I will come to the first topic, that is concept of physics. What is this? This is a schematic diagram of a prism. P, Q, R, S, T, U. This one is the prism, okay, and the sides of the prism. In the middle we have considered a section that is called a principal section. See, I have written over here, it's ABC. Okay. Now what is PT? PT is the straight line. This is called as edge. Okay. So the ABC is the principal section and PT is the edge. Okay. Now we'll come to this topic. What is it? This diagram. This is a ray diagram. What we find over here, that PQ is the incident ray. Okay. And RS is the refracted ray. The light enters from here and then exits from here. Okay. See, AB and AC are the refracting surface from where the light actually gets refracted. This AB and AC are the refracting surfaces of the prism. Now we'll see that BC is the base. Now what is base? Base of the prism is this one. Base is what? Simply we say the prism is kept on the table with support of its base. Okay, so this is called as base. And what is A? A is the angle of prism. Okay. Now we'll come to another topic. This is angle of deviation. Okay. What we will see is the angle of deviation of the light ray. Here is the diagram. See, I'll be explaining this. What we see here is for surface AB, the first surface, the ray PQ enters here and the ray RS exits over here. Okay, PQ, QR and RS. Okay, see, this diagram has been repeated over here. This one, okay. Now you see this NM, I hope you can see the cursor. NM and MO are the normals, that is perpendicular to the surface AC and AB. Okay, so the incident angle is I1 and the normal made with the angle made with the normal is R1. Okay, and the emergent angle is simply I2. Okay, now what we see that PQ can be extended forward in this direction, right? But it bends away from this normal. Okay, so this angle is termed as del 1. Why? Because there is a change in the medium and the light actually bends away or bends towards the normal. Here it bends away. Okay. Similarly, we will be extending it backward. This RS we will be expanding backward. So you see this angle made with this normal is del 2. Okay, so here we will be finding the total angle of deviation. So for AB surface, first surface, incident angle is I1. Okay, angle of refraction is R1 or R2. Okay, from the diagram we can see that normal is NM. Okay, now what you see is from the diagram you can see this vertically opposite angle. See, from here I1 is equal to del 1 plus R1. Similarly for AC surface you will be saying that I2 is equal to del 2 and R2. So we have write down it over here. Okay, I1 is equal to del 1 plus R1. Okay, so del 1 is equal to I1 minus R1. We just maintain it properly. We will be finding the angle of deviation. That is why we are keeping it on the left hand side, okay, of the equal to sign. Similarly, for AC surface, we get del 2 is equals to I2 minus R2. Okay. Now what we do is, therefore, the total angle of deviation. Now what we got is del 1 and del 2. We just simply add these two angles and we will be getting the final total angle of deviation. Okay, so del is equals to del 1 plus del 2. We simply write these equations over here, I1 minus R2 plus I2 minus R2. We just write it sequentially, I1 plus I2 within a bracket, then we take a common sign and then R1 plus R2. So we name this equation as number 1 equation. Okay. Now see, we will be considering from this triangle. You see there is a triangle QMR. Okay. If I show you over here, see, this is Q, M and R. I mean this triangle. Okay. Let me show it to you with the help of this. See, this is QMR. Okay. Triangle QMR. Okay. What we see in triangle QMR is R1 plus R2 and QMR equals to 180 degree. We know that the total angle of a triangle is 180 degree, right? You see, I'll be going back. QMR has angle R1, R2 and angle QMR, right? So here R1 plus R2 plus angle QMR gives you 180 degree, this one. Okay. So we calculate angle QMR, that is 180 degree minus R1 plus R2. Again from quadrilateral, this AQMR. Let me show you this AQMR. Using this, what we see is the angle sides of the parallelogram is equal to 360 degree, right? So what we will do is angle A plus this total angle. Okay, what is this total angle? That is AQM. You see, AQM. Then QMR. Here it is QMR. Then you see here is MRA. So here it is MRA. Now adding all these angles, we get 360 degree. Okay. Now we will be putting the values. Now what is AQM and angle MRA? What are those? See, AQM. It's actually 90 degree, right? You see, it's 90 degree. Let me show you. This is 90 degree, right? Isn't it? It's 90 degree. This one is, when this one is 90 degree, this is a normal. So this is also 90 degree, right? So this angle, and similarly this angle, that is MRA, is also 90 degree. Fine. And then we have already calculated value of QMR, that is 180 minus R1 plus R2. We substituted over here and then we find this equation. Okay. Now what is A? A is R1 plus R2. How did we get that? We just simply calculate this. See, 360 degree plus 90, that is 180. Okay, again plus 180, that is 360. We take it over here, we get 0. So then we finally get value of A as R1 plus R2. Now using equation 1 and 2, what was our equation 1? Equation 1 is this one. Okay, I1 plus I2 minus R1 plus R2. And equation 2 is this one. We just simply write the value of R1 plus R2 in equation 1. We have got R1 plus R2 is equals to A. So we simply substitute it over here and we get that value of del, that is angle of deviation, is I1 plus I2 minus A. Got it? So this is the expression for angle of deviation. Okay. Now we will come to another topic. Okay. Another topic, that is angle of minimum deviation. Now, what is angle of minimum deviation? What we calculated before was the angle of deviation, right? This del. Now we will be calculating or finding the expression for angle of minimum deviation. That is for what value, what will be the minimum value of del, this del. Okay, so that is called as minimum deviation. So this is a graph how we will be calculating the value of angle of minimum deviation. What we do is that simply we pass a light on a prism. The light is incident on a prism. Okay, and then we will be measuring the angle of deviation. Okay, simple light is incident at certain angles, say 10 degree, 15 degree, 25 degree, 30 degree, and we will be finding the angle of deviation. See, if we plot those calculation, what is the graph? Graph would be angle of deviation versus angle of incidence. This is the nature of the curve. Okay, you see there is a down point over here in the curve. What does this signify? This actually signifies del m, that is the minimum deviation. There you will get a corresponding one value, okay, just one value of I. For other del, for other angle of deviation, you actually get two angles of incidence. Okay, here it is I1 and I2. So this is important. This one is important. That is, this is the minimum. At minimum deviation, del is equals to del m. That means that angle of incidence equals to angle of emergence. What we see is that angle of incidence is equal to angle of emergence. That is, the light entering the prism and the light when the light leaves the prism are actually same. The angle formed are actually same. So in that condition, we will be getting minimum deviation angle. Okay, angle of incidence is equals to angle of emergence is one such condition to get the angle of minimum deviation. Okay, now what we can say is here I1 is equals to I2. Say we call it as I, because angle of incidence is equal to angle of emergence, right? So we named it I, and so the minimum deviation will be I plus I. Why? Because we know that expression for del was I1 plus I2 minus A, right? Previously we found that relation was for expression for angle of deviation was del is equals to I1 plus I2 minus A, right? So here we just simply substitute these values as I. So instead of I1 and I2, we write it I plus I minus A, we get 2I minus A. Now this one is the relation for angle of minimum deviation. Okay. Now see, note one thing. What happens is, since your I1 and I2 are same, therefore R1 and R2 will also be equal. See, what was R1 and R2? We saw it over here, R1 and R2. If your incident angle and this emergent angle are same, then the refracted angles R1 and R2 will also be same, right? So this is another such condition that at minimum deviation we get R1 is equals to R2. Okay, and what is the good thing about this condition is, or this topic is, that we find that the light refracted from the surface AC is actually the brightest. Okay, the brightness of the refracted light increases in this condition. What is the condition? Conditions are that angle of incidence has to be equal to angle of emergence and that R1 and R2 will be equal. Okay, so we got this. These were the two conditions for angle of minimum deviation. Okay, now we will see one such image. You see, here a white light is incident on a prism and we see that it gets refracted into 7 different colors. Okay, so white light, the principle of the prism is, what does prism actually do? Prism actually breaks a white light into 7 different colored light. Okay, what we see here in the second image is that prism is showing incident ray, reflected ray and the refracted ray. This is the incident ray. A part of the incident ray gets reflected and a part of the incident ray gets refracted and it is split into 7 different colors. Why does it happen? Because a light travels with a different speed inside a particular medium. Okay, so the wavelength for different light is different, right? So therefore we see different colors of light after refraction. Okay, so this is the main principle of the prism. Now we have another topic, that is the relation between del m and mu of the prism. That is, del m is what? Minimum angle of deviation, and mu is the refractive index of the prism. Now what is angle of deviation? We actually calculated that del is equals to I1 plus I2 minus A. This is something like this. Okay. Then angle of prism, which we have calculated, the angle of the prism is R1 plus R2. We have already calculated this. And at minimum deviation of prism position, what was the condition which we saw previously? Was at minimum deviation position that I1 angle of incidence will be equal to angle of emergence. So that was taken as I, and similarly R1 and R2 will be equal. We said it as R. Okay, and del we considered it as del m because it is angle of minimum deviation point. Okay, we already know that del m is equals to 2i minus a. We just calculated it before. See, 2i minus a. You can see my cursor over here. Okay, so we write it over here. Therefore del m is equals to 2i minus a. What we do is we find the value of I. I is equals to del m plus a. We just recalculate it. Okay, then del m plus a divided by 2. We already know a is equals to r plus r, r1 plus r2. Since we are saying it as r, we substitute the values of r1 and r2 as r, and we get the value of r as a by 2. A is the angle of prism. Now from Snell's law, what is Snell's law? Snell's law is sin I is equals to mu sin r, or mu is equals to sin I by sin r. We already know the formula for Snell's law. Okay, so we will be calculating the Snell's law at surface 1. Okay, so sin I1 is equals to mu sin R1. We get this. Now we just substitute the values of I and R in this equation. What is the value of I? We have find that I is equals to del m plus a by 2. We simply substitute it over here, right? This one. See. And in place of R, we simply substitute the value of R, that is a by 2. A by 2. Okay. So we got the value for mu. What is mu? Mu is the refractive index of the prism, and this is the expression for the refractive index of prism. Okay. Now we will be learning something about thin prism. What is thin prism? Thin prism is basically a prism whose angle of refraction or the angle of the prism. What is a thin prism? A thin prism has a angle of refraction or the angle of the prism as 10 degree. Okay, what is angle of refraction? This one, see, this is the angle of refraction or the angle of the prism. Okay, so if the angle of the prism is less than 10 degree or it's very small, then we consider that prism as thin prism. Okay, now we will be seeing that angle of deviation. What happens to the angle of deviation in a thin prism? We will be calculating del. Okay, we will be calculating this del. We already know that del is equals to I1 plus I2 minus A. Okay, I1 plus I2 minus A. And we also know that angle of the prism is R equal to R1 plus R2. So in case of angle of deviation, what we find here is I2 is equals to del plus A minus I1. Since we need to find I2, we just keep it on the left hand side. Okay, now this is a diagram, okay, of a thin prism. Now this angle is effectively very small, so we will be applying Snell's law. Okay, what we will be applying Snell's law in the surface AC. Okay, simply we know sine I is equals to mu sine R. Okay, now here sine I2, what is sine I2? Why sine I2? Because this is in the medium of air. Okay, so here the refractive index is 1. Okay, that is equal to mu. What is mu? Mu is the refractive index of the prism, and the angle formed here in this surface is R2. So we write this expression as sine I2 is equals to mu sine R2. Okay, now we will be just substituting the values of I2 from here, that is del plus A minus I1. We write it down over here, that is equals to mu sine A minus R1. Why? Because value of R2 from here is, from this equation is R1, R2 is equals to A minus R1. So we write it down over here. Now what we will do is we will be using trigonometric function or trigonometric formula. What is that? That sine A minus B. What is sine A minus B? Sine of A minus B is sine of A cos of B minus cos of A into sine B. This is a trigonometric formula. We are aware of that, right? So we just break this equation in trigonometric formula. Okay, similarly this one, sine A minus B, is again broken into the trigonometric formula like this, right? Now we know that for the thin prism, angle of the prism is very small. A is very small, as we just learned that it's less than 10 degree or even smaller. So similarly, angle of deviation will also be small. Okay, now we know that sine theta is equal to theta, and cos theta equal to approximately equal to 1. This is actually approx sign for small angles, right? We know that for small value of theta, we get sine theta as, please ignore my bad handwriting, theta is equals to small, for small angle of, for any small angle, value of sine theta is approximately equal to theta, and value of cos theta is approximately equal to 1. So we wrote down it over here that value of sine del plus a is approximately equals to del plus a, that is theta, and cos of any angle is approximately equal to 1. Right? Now we will be just substituting these values in the previous equation. We write here as del plus a. In case of sine, we wrote down del plus a. Okay, the sine I1 remains same. Here we had cos of del plus a, so we wrote it 1 over here. Sine I1 remains same. Now mu is there, and in place of sine a, we wrote only a because it will be changing to only the angle. Cos I1 remains same, and here the value of cos a, that is 1, this is 1. So here the value goes to 1, which I haven't written over here. Okay, so we got this equation. Now we just write it in sequence. We just do the algebraic calculation. Okay, so all over, this has been broken, this has been expanded in this form, mu a cos r1 minus mu sine r1. Now since mu, we all know that mu is equals to sine I by sine r, right? Now del plus a into cos I1 from here is equals to mu a cos R1. Why? Because we already know that from this equation, from this formula, what we get is mu of sine R1 is mu into sine R1 is actually sine I1. So we just write the sine I1 in this place. So this function, this part and this part actually cancels out, right? So we finally get this equation. Got it? Now we will be calculating the value of delta from here. Just do the simple algebraic calculation. Then you finally get the value for delta. For what is delta? Delta is the angle of minimum deviation for, that is for thin prism. Okay, this formula is for thin prism. Okay, where a is the angle of the prism. Okay, let me solve this. Now see, there are two cases, case 1 and case 2. What is case 1? Case 1 is for small angle of incidence. Small angle of incidence means the angle formed with the normal when the light is incident is small. So if the angle of incidence is small, angle of refraction will also be small. So I1 and R1 is taken to be small. So if these angles are small, then we can say that cos of R1 and cos of I1 will also be small, will be approximately equal to 1, right? So here in this equation, we just substitute the values of cos R1 and cos I1 as 1. So after substituting, what we get is del is equals to mu minus 1 into A. Okay. What is case 2? Case 2 is for perpendicular incidence of light. What is perpendicular incidence of light? That means there will be no angle formed between the incident ray and the normal, because it is perpendicular, that is, it actually falls on the normal of the prism. Incident angle, the angle formed between the incident ray and the normal is 0 degree because it falls perpendicularly. So therefore the angle formed, the refracting angle formed with the normal will also be 0 degree, right? I1 and R1 both will be 0, right? Now we will just substitute these values in cos R1 and cos I1. Now what is cos R1? R1 we got it is 0 degree and I1 is also 0 degree. So by substituting the values of R1 and R1, we get that cos 0 degree is 1, this, and cos R1 that is 0 degree is again 1, right? So after getting the values 1, we substitute it again in this equation. Then what do we get is, again we get the same result, that is del is equal to mu minus 1 is equal mu minus a into mu minus 1 into a. Okay, that means we can conclude that in the case of thin prism, what happens, that del does not depends on the angle of incidence. See, this del doesn't have any I1, that is, it is independent of I1, that is angle of incidence. This question is important. You may get this question, that what is the how does angle of incidence depends on minimum angle of minimum deviation. For thin prism, you will say that it is independent of angle of incidence, right? Now what we conclude is that the value of del is most of the time, actually maximum times, it is same. The result will be same, that is del is equals to mu minus 1 into a. This result will be constant for many values of a. Okay, now we will be getting to our next topic, that is numericals. Okay, what is question number 1? Question number 1 is, an equilateral prism of refractive index. What is equilateral prism? Equilateral prism is a prism whose all sides are same. Basically in schools and colleges you will be seeing an equilateral prism. Okay, schools and colleges usually use an equilateral prism, that is the sides of all the sides of the prisms are, all the sides of the prism will be 60 degree, will be 60 degree. Okay, that is equilateral prism. Now what we say, that see that an equilateral prism of refractive index is 1.6, which is immersed in a liquid of refractive index 1.33. Now you see, what liquid is this? Can you tell me? This is actually the refractive index of water, that is 3/4. We know, right? That is 4/3. Sorry, it's the refractive index of water. So this liquid is nothing but water. Now we need to find the angle of minimum deviation for this numerical. So what we have here is angle of the prism. What is the angle of the prism? We know that the prism, equilateral prism, has 60 degree. All of its size is 60 degree. So therefore the angle of the prism will also be 60 degree, right? Now we know the refractive index of the prism is 1.6, already given. Refractive index of liquid is 1.33. It's also given. Now we need to calculate the refractive index of prism with respect to liquid. First we will be calculating the refractive index of the prism with respect to liquid. Now what we do in that case is that with whose respect you want to calculate it with respect to liquid. That would be written in denominator, that is mu L, and whose refractive index are you going to calculate? That is mu P, that is the refractive index of the prism, mu P. We know refractive index of the prism is 1.6 and of liquid is 1.33. So we get the result as 1.2. Okay, now we know that angle of minimum deviation is equal to del m. We supposedly we have taken this as del m. Now we know the relation of refractive index we have calculated before, that was sine del m plus a by 2 divided by sine of a by 2. Remember that this 2 is within this whole bracket, okay? Now we substitute the values. We have calculated refractive index of the prism with respect to liquid, that is 1.2. We just substitute all the values. We have a as 60 degree and a by 2 will be 30 degree, okay? We just do the algebraic calculations and you take the value of sine, and you will be calculating it as sine inverse function using it in your calculators, and then you will get the result as del m is equals to this particular degree, that is 13.74 degree. So this is the minimum angle of minimum deviation for this numerical, right? Now coming on to the second question. What is the second question is, a prism of refractive index 1.5 has same angle of prism as that of angle of minimum deviation. Then find the angle of prism. That means the prism has the angle of minimum deviation and the angle of the prism similar. No, actually these two angles are same, so therefore we can conclude that angle of prism is equal to angle of minimum deviation. We got this. Now we know from our previous calculation that refractive index is equals to sine of del m plus a by 2. This formula is very important, and whole divided by sine of a by 2. Now we just substitute all the values, that is mu, value of mu is 1.5, right? Sine a plus a, why a plus a? Because a and del m are same. So we just substitute a in place of del m. Then we do the normal algebraic calculations. Then here we get again a trigonometric use of a trigonometric formula. What happens is sine of 2a is equals to 2 sine a cos a. This one, 2 sine a cos a. So sine a gets divided into a gets divided by 2, a by 2. So we get the angle gets divided by 2. So sine a is equals to twice of sine a by 2 into cos a by 2. So this way sine a by 2 and sine a by 2 cancels out. So we get only 2 cos a by 2. This one. So we got this equation. Now we will be calculating the inverse cos inverse function, and we get the answer, that is angle of the prism is 82.82 degree. So this ends our class. Thank you so much students for listening to this lecture. I hope you all understood it. We will continue the rest part in the next class. Thank you.